start with thermodynamics rapid revision class. Okay, so in this class we are going to study only theory part, like important topics from where you can expect the questions. It's like a rapid revision. Okay, so let us start the today's class. So first of all, what is the meaning of thermo? The word thermo indicates what? The word thermo indicates that it is a heat. Okay, thermo indicates what? Heat, or you can call it as what? Energy. Heat or energy, right? Going to the next one, dynamics. Okay, what is the meaning of dynamics? Flow or motion. Flow, or what we can call it as a motion. That means flow of heat. We are going to study in this chapter how heat is flowing, whether heat is released in the chemical reaction or heat is observed in the chemical reaction. Okay, so all that means everything related to energy and heat we are going to study in this chapter. Okay, so there are total 3 basic terms. Okay, the first basic terms. Okay, first we are going to study what? Basic terms. Okay, so what are the 3 basic terms here? The first one is system. Okay, and the second one is what? System surrounding. System surrounding, and the last one is what? Universe. Okay, so actually what happened here, coming to system surrounding and universe. So what is this actually? This system, what is the meaning of system? The one on which we people are studying. Okay, so the one on which people are having observation. Okay, the one on which people are keeping your observation is called system. Surrounding is what? Other than system. Okay, other than system, remaining everything is called surrounding. What is a universe? System plus surrounding. Okay, now let me give a small example regarding system surrounding and universe. Suppose this is a room. Okay, and here one beaker is there. Okay, inside beaker chemical reaction is happening. Okay, so you people are mainly focusing on what? You people are mainly focusing on what? On the chemical reaction, right? So in this case what happened? The chemical reaction, okay, the chemical reaction is acting as what? System. Okay, other than that, remaining every part, this part, okay, this remaining part is acting as what? Surrounding. Okay, so this everything, system plus surrounding, we should call it as what? Universe. Okay, now what happened? This system is system and surrounding. Okay, system and surrounding is separated by a wall. Okay, and this wall you should call it as what? Which is nothing but uh, boundary. Yeah, boundary. Okay, so who is going to separate the system and surrounding? Boundary. For example, a small example, suppose if you people are studying about fan, then the fan is called system. If you're talking about, if you're focusing, or you can say if you're studying about any window, then window is acting as what? System. Okay, if you're talking about apple, then apple is acting as system. If you're talking about chemical reaction, then chemical reaction is acting as a system. If you people are talking about vessel, then the vessel is acting as what? System. So what is the meaning of system? The one on which you people are doing the study. Okay, so other than system, remaining part, everything is called as a surrounding, and system plus surrounding will give us what? Universe. Okay, system surrounding is separated by what? By a wall called boundary. Okay, so now this system. Okay, now let us try to focus, since we are talking about so in this chapter we will mainly going to focus on what? System, because system is the one on which we people are studying, right? So based on this, system is divided into, okay, system is classified into 3 types. What are those? Open system, right? Next, closed system, and the third one is what? Open system, closed system, and last one is nothing but what? Isolated system. Isolated system. Okay, in open system what happened? Okay, energy. Okay, and other side what I'm going to take? Energy and matter. Okay, and here I'm going to take one example. Okay, for example, in first example, what happened? Open system means definitely there should be one opening. Okay, here what I'm going to do, I'm going to take some hot water. Okay, so after 1 hour, okay, or else I will say after 5 hours. Okay, so you people are taking 5 ml water. Okay, after 1 hour also the water will be as it is hot water? No, obviously water is going to become cool. That means, can I say heat is exchanged with the surrounding? Before it was hot, now it became cool. That means what happened? Energy exchange takes place. And remember, in this chapter, heat or energy, you can use any one word. Okay, you can say energy is exchanged, or if you want you can use the word heat is exchanged. Okay, now what happened? After 5 hours also the 5 ml water will be as it is, or it going to decrease? Obviously it is going to decrease because of what? Evaporation. Now what happened? Matter exchange is also takes place. Okay, in which case? In case of open system. Whereas in closed system, for example, if I take a closed system, and what I'm going to do, I'm going to fill the hot water. Okay, and here the wall is made up of what? The wall is made up of diathermic. Okay, so here a new word people are going to learn. What is that? Diathermic. What is the meaning of diathermic? Diathermic means which allows the heat exchange. Which allow heat exchange. The one which allow the heat exchange, the wall which allows the heat exchange is called diathermic wall. Now what happened here, I'm taking once again 5 ml hot water. Okay, after 5 hours what happened, the hot water will be as it is? No, because the wall is allowing the heat exchange. That means after 5 hours what happened? After 5 hours the water is going to become cool. That means what happened? Energy exchange takes place. Okay, but 5 ml will be as it is, or its value will be decreases. Obviously it is as it is. Why? Because it is a closed vessel. There is no chance of exchange of water outside, right? So matter exchange will not take place. Coming to the isolated system, in isolated system what happened? Whatever, once again we are going to take the same thing. Okay, and here I am going to take as it is condition, like I am going to take hot water. Okay, this is also hot water like the previous one, and here also I'm going to take 5 ml. But the difference between the closed and isolated is what? For closed isolated system, we are going to surround it with one wall, one extra wall. Okay, and this extra wall we should call it as let it be it is nothing but insulated one. Okay, okay, the wall is what? Insulated. What is a what is this insulated? Insulated means what here? No heat exchange. Okay, or you can call it as a adiabatic also. The wall can also be written as what? Adiabatic. Okay, what is the meaning of adiabatic? Okay, there is no heat exchange. Okay, so now what happened here? After 5 hours what happened? The heat is going to be hot, hot water is going to become cool? No. Why? Because it is insulated. Insulated wall means there is no exchange of heat. So now what happened? Energy exchange is not taking place. After 5 hours what happened? The water is going to escape anywhere? No, the matter is also not going to exchange. So these type of, there are total 3 types of system based on what? Exchange of energy and matter. Clear till here? Right, so let us go for the next example. So moving to the next one, types of function. Okay, so coming to the function, there are total 2 types of function. Types of function. Okay, so what are the 2 types of function? We have total 2 types of function. So one, let us talk about the first one. The first one is state function. Okay, the first one is state function, and the second one is path function. Path function. Okay, state function and path function. So let us try to understand what is the meaning of state function, what is the meaning of path function. Okay, state function is the one where properties, the properties which depends, the properties will depend on, okay, or you can say doesn't depend upon path, depends on initial and final state. Initial and final state. That means initial point and final point. Okay, what is the meaning of path function? Properties which depends on path of the system. Okay, you can say path of the process, but not on the initial and final. Okay, for example, if I take this is a initial point, okay, this is the final point. Okay, and you people are traveling from here to here. So the one which depends upon only initial and only final, but not on the part, those properties we should call it as a state function. The properties which depends upon the blue line, that means only path but not the initial and final, those are called path function. That means the properties which depends on the blue line is called path function. The properties which depends upon this pink color initial and final points are called state function. I hope you people understood the difference between state function and path function. Now it's very important to remember the examples of state function and path function. Okay, now actually what happened in path function, there are only 2 examples for the path function. Okay, so to how many examples we have for the path function? 2 examples. What are those? Heat and work. Okay, so in this chapter heat is denoted by small q, work is denoted by W. Okay, so except to these remaining whatever the examples we have, everything are what? State function. For example, I can call it as what? Volume. Okay, volume, temperature, okay, pressure. Okay, next you can take enthalpy. Okay, enthalpy is denoted by which letter? H. Enthalpy, entropy. Entropy is denoted by which letter? S. Next, Gibbs free energy. Okay, Gibbs energy, which is denoted by which letter? G. etc. That means the only thing you have to do is just remember the example of what path function. Why? Other than this, remaining everyone will acting as what? State function. So these are the examples of what? State function and path function. Moving to the next one. The next one is nothing but properties of a system. So the third concept is what? Properties of a system. Properties of system. Let us try to understand how many properties we have. Total 2 properties we have. Okay. The first one is extensive property. Okay, extensive property. Okay, in the shortcut I'm going to write EP, extensive property. Okay, and the second one is nothing but intensive property. Okay, intensive property. Okay, it is denoted by the letter I. Okay, now let us try to understand what is extensive property and what is intensive property first of all. Okay, for example, what I'm going to do, I'm going to take the first example, I'm going to talk about the volume. Okay, so for example, if I take here 1 liter water bottle. Okay, so here water is filled here. Okay, this capacity is how much? 1 liter. Okay, now if I break, okay, if I break, so what you are going to get? Obviously, you are going to get what? 500 ml and 500. Okay, so the property which upon breaking value changes, then those properties we should call it as a extensive property. Okay, that means they are depending upon the quantity of matter. Okay, whereas suppose if I take a room, okay, suppose if I talk about temperature, okay, let us take an example of temperature, right? For example, there is a room, okay, and what is the temperature of this room? 10 degrees Celsius. Okay, now what I'm going to do, I'm keeping one wall in the room. Okay, just by keeping wall in the room, do you get 5 degrees Celsius and 5 degrees Celsius? No, it's not possible. Though if you break the room into 10 parts also, the temperature of the room is always same. What is that? 10 degrees Celsius. That means the properties which doesn't change even after breakdown also, those type of properties we can call it as what? Intensive property. I hope you people got the clarity. So the trick here is nothing but I letter. I means what? Independent. After breaking also the value is independent. That means the value is not going to be changed. Okay. So intensive property means what? Independent. Extensive means what? Dependent. Now let us try to write down the examples of what? Extensive property and intensive property. Okay, the important thing is you have to remember the example. Try to understand and by heart the example. Don't directly by heart the example. Okay, example is what? Volume. Okay, if I take 5 kg pencil, if I take a 5 kg stick, okay, if I break, can I say mass is going to be divided both the side, right? So that means mass is also acting as what? Extensive property, right? Next, in the same way, next one, heat capacity. Okay, heat capacity denoted by the letter C. Okay, next after that, internal energy. All thermodynamic words. Thermodynamic words like internal energy. Okay, denoted by the letter U or E. Next, after internal energy, enthalpy. Okay, enthalpy is denoted by the letter H. All thermodynamic words. Okay, enthalpy. Next, whatever left, entropy. Okay, entropy denoted by the letter S. Next, Gibbs energy. Okay, Gibbs energy denoted by the letter what? G. Okay, clear till here? So etc. So all these are what? Extensive property. Now let us try to understand the intensive property example. So first example of intensive property is what? Temperature. Okay, next you can take the pressure. Now you will say, ma'am, how pressure will become intensive property? Okay, suppose your room has 1 atmospheric pressure. If you break, do you get 0 0.5, 0.5? No, it's not possible. So that means pressure is also what? Intensive property. Okay, next you can take what? Density. Okay, for example, just think and try to by heart the example. Okay, suppose you people took the water. Because how many water you have? How much amount of water you have? 10 ml. And what is the density of water? 1 gram per ml. Okay. Now what happened if I break the beaker into two parts? Do you get density is equal to 0.5 gram per ml? No, that means density doesn't depends upon this quantity, right? So density is acting as what? Intensive property, right? Next, after that, moving to the next one, specific heat capacity. Okay, you can say molar heat capacity. Molar heat capacity. Next, specific heat capacity. Specific heat capacity. Okay, next, the most important terms are from here. Surface tension. Okay, next you can say electrode potential. So what is electrode potential? You can clearly understand if you go through the electrochemistry chapter. Okay, electrode potential is an extensive property. Okay, electrode potential. Next to concentration terms. Why concentration terms are intensive property? Suppose the solution is 1 molarity. If I break the solution, do you get 0.5 molarity, 0.5 molarity? No. That means all concentration terms are what? Our intensive property. Next, pH value. For example, here the solution, whatever the solution I took, here its pH value is 5. Okay. If I break the solution, do you get pH is equal to 2.5, 2.5? No. The solution of pH is remain throughout it remains same. So that means pH is what? Intensive property. Clear till here? Next, refractive index. Okay, refractive index. Clear till here? So these are few important examples for regarding the intensive property. Okay, let us write few important points here. So the most important point is nothing but there are total two important points. The first important point is whenever you divide, okay, extensive property divided by extensive property, what you are going to get? Intensive property. Okay, let us take one small example. Density is equal to what? Mass by volume. Okay, as you people know, mass is what? Extensive property. Volume is what? Extensive property. So therefore density is acting as what? Intensive property. Okay, and the second example, second important point is whenever you use the molar, okay, whenever you use the word molar to extensive property, it is going to convert into what? Intensive property. For example, if I write enthalpy, okay, generally enthalpy is what? Enthalpy is our extensive property or intensive property? Extensive property. Okay, but if I use the word molar enthalpy, if I say the molar enthalpy, okay, so what you are going to get here? Intensive property. That means whenever you use the word molar, okay, not only molar, okay, if you go for anything else like molar, specific, okay, all these will come under what? All these will come under our intensive property. Clear till here? Not only molar, if you use the word specific, etc., okay, molar or specific, any word if you are using, it indicates what? Extensive property is going to convert into intensive property. Okay, now the third most important point is nothing but, okay, the third most important point is nothing but, let us try to understand. So you can see that in extensive property and intensive property, I didn't written anywhere work and heat. Okay, you can see that there is no work in the examples, there is no heat in the example. Okay, now we want to know whether the work is a extensive property or intensive property. I want to know that heat. Okay, heat is what? Whether it is a extensive property or intensive property. So actually what happened, it is not extensive nor intensive. Okay, these are what? These both are boundary. These are what? Boundary. Remember, very very important. Work and heat are boundary. They are neither extensive nor intensive. But suppose in case in the option, if you don't find the boundary, then go for the extensive property as a option. But generally first priority is what? The first priority you should give for what? Boundary. Whenever I ask you like heat and work are will come under which property? Extensive, intensive or boundary. So you have to answer boundary. But in case, in very rare cases, if they don't provide the option boundary, then you have to go with what? Extensive property. Okay, right, moving to the next one. Now the basic terms in this chapter. Okay, thermodynamics words we are going to start. Okay, thermodynamic words. So what are the thermodynamic basic words we are going to study in this chapter? Okay, first of all, you people are going to study what? First of all, we are going to study internal energy. Okay, internal energy denoted by which letter? U or E. First of all, you should be have clear cut clarity regarding the letters. Some people think that E for enthalpy. No, it's E for internal energy. Okay, and the next one is what? Enthalpy. Okay, enthalpy is denoted by the letter H. Later we are going to study entropy. Okay, entropy denoted by the letter S. And in the last we are going to study what? Gibbs free energy. Okay, Gibbs free energy. Okay, denoted by which letter? Denoted by the letter G. Clear till here? So let us start with our first thermodynamic word. The first thermodynamic word is nothing but internal energy. Okay, internal energy. So let us try to understand here internal energy. Generally it is denoted by the letter U or E. Okay, so let me explain you what is the meaning of internal energy. Okay, here internal energy is nothing but energy present inside the system. Okay, shortcut, like in a simple language, what is internal energy? Energy present inside the system. Okay, inside the system. For example, what is the meaning of system? The one on which we people are studying. For example, I'm talking about, and we are studying about fan. Then the fan is called system. Energy present inside the fan is called internal energy. Suppose if I'm talking about student, then student is called internal, then student is called system. Energy present inside the student is called internal energy. Okay, now what happened? Internal energy means it's nothing like new. Internal energy combination of all types of energy, like it may be kinetic energy, potential energy, vibrational energy, rotational energy, anything. Okay, for example, if I'm talking about fan, then fan is acting as what? System. Energy present inside the fan is called internal energy. But which type of energy present inside the fan? You can say like rotational energy. Okay, that means internal energy is a combination of all types of energy. Clear till here? Next, the next point we can say that you cannot find the exact value of u. Okay, you can always find the delta u. That means internal exact value of internal energy is very difficult to find, which is not at all possible. So now what we have to do, we can find change in internal energy value. Okay, next, internal energy is a extensive property or it is a intensive property. Yes, as I said, all thermodynamic words are extensive property only. Okay, when it is acting as intensive property, if you use the word molar or specific. Okay, next, it is a state function or path function. Can I say the given is a path function? Why? State function has only two examples. What are the two examples of state function? Work and heat. Clear till here? Right, so moving to the next one. So based on this, we are going to study by using the concept of internal energy. We are going to study first law of thermodynamics. Okay, first law of thermodynamics. Thermodynamics. First law of thermodynamics, which is nothing but FLOT. First law of thermodynamics. Okay, when you can study first law of thermodynamics, if you have a clearly concept of what internal energy. Let me ask you again, what is internal energy? Energy present inside the system. Okay, right? Can we find out exact value of internal energy? No, but we can find out what change in internal energy. So what is the other name of first law of thermodynamics? Okay, it is also known as, okay, it is also called what you can call law of conservation of energy. Law of conservation of energy. Okay, now what does the law of conservation of energy says? Energy can neither be created nor be destroyed, but it can be transferred from one form to the another form. It can be transferred from one form to the another form. Okay, now what does the first law of thermodynamics says? First law of thermodynamics says that energy, okay, let me write a little bit clearly. Right, so what does it says? Energy, okay, can neither be created, energy can neither be created nor destroyed, not destroyed, but it can be transferred, it can be transferred from one form to, from one form to another form, to another form. Okay, so what does this law of conservation energy says? That what does the first law says? First law says that you cannot create any new energy, you cannot destroy the present energy. That means in this universe you cannot create any new energy, and as well as you cannot destroy the present energy. That means, can I say energy is always constant in our universe? Yes or no? Because you are not able to create any new energy, you are not able to destroy any present energy. Therefore, what will be the second definition of our first law of thermodynamics? Energy of the universe is always constant. Energy of the universe. Energy of the universe is always constant. Energy of the universe is always constant. Okay, now let us try to understand the formulas here. So now coming to the formulas of the first law of thermodynamics, very important. Many times, suppose there are 100 questions on the thermodynamics, okay, definitely from that 60 to 70 questions are from first law of thermodynamics itself. Okay, so let us try to understand here. What is the first formula? Delta U is equal to Q plus W. Okay, what is here? Delta U is equal to Q plus W. This is the first law of formula of what? First law of thermodynamics. Okay, in this, what is the meaning of delta U? U indicates what? And one more thing, in some books you can see the word E letter also. E for internal energy or enthalpy. Internal energy, enthalpy is H. Okay, delta E is equal to what? Q plus W, both are same. Okay, here delta U or delta E, what is the meaning of this? It says that change in internal energy. Change in internal energy. Okay, next, what is the meaning of Q? Q is nothing but heat. Okay, W is nothing but what? Work. Heat and work are extensive property, intensive property, or boundary. Yes, they are boundary. If they don't provide the option of boundary, then go with the extensive property. Okay, heat and work are state function or path function. Obviously it is a path function. Okay, right, moving to the next one. Note. Okay, under the note, what we have to just remember this formula enough to solve all the question. What is that? Delta U is equal to Q plus W. Okay, under the note, what happened? Delta is try to write on the first formula. Sometimes you will get plus Q. Okay, sometimes you will get minus Q. Okay, now what happens? Sometimes you will get plus W and sometimes you may get the minus W. Okay, what is the meaning of heat? Q heat means what? Heat. Okay, so plus indicates what? Suppose I'm talking, since see now, suppose there is a vessel. If we are talking about vessel, then vessel is acting as what? System. If system, when the system will get positive, if it absorbs the heat or if it releases the heat. Obviously when system releases the heat, you will get the negative charge. If the system absorbs the heat, it will get positive charge. So what is the plus Q indicates? Heat absorbed. Heat absorbed. Plus means benefit, minus means loss. Okay, plus indicates what? System is getting benefit. When the system will get benefit? If heat is absorbed. So heat absorbed by system. What is the meaning of minus Q? Q indicates what? Heat. Minus indicates what? Loss. That means what you can say? Heat released by the system. Heat released by the system. Okay, plus means what? Plus means what? Benefit. Benefit means what? Work done on the system or by the system. When the system will get benefit? If work done on the system. On the system, if someone is going to do work on the system, then the system will get benefit. When the system get loss, if system is doing the work. So what we can write here? Work done by the system. Work done by the system. Clear till here? Right, now what happened actually? So the most important point is, since as I said, delta U is equal to Q plus W. Okay, I think people, just now we are done with detailed discussion regarding what is internal energy, what is its definition. Okay, but we didn't discuss what is the heat, types of heat. We didn't discuss what is work, what are the types of work. Okay, now let us try to understand the work related. Okay, right, so generally work is of two types. Okay, let us try to understand here. Right, so coming to the work, so now we are going to study, this is not the second, this is just a concept. Okay, concept of the work. Okay, this is not a thermodynamic word, you can call it as what? This is one concept denoted by what? W. Okay, so now what happened here in this case? There are total actually work done may be of two types. Okay, first of all, in the first category, work is of two types. What is that? It may be expansion work, okay, or it may be compression work. Okay, it may be expansion work or it may be compression work. What happens in expansion? For example, there is a what you can say, this is a piston system. Okay, here the level is what? Let's suppose here the level is 3 liter. Okay, expansion means what? Expansion means the piston will go up or it will come down. Expansion means what? Piston will go up. Okay, when the piston is going up, okay, so it reaches to 5 liters. Okay, now what happened here? When does the piston will go up? Who have to apply the pressure here? System has to apply the pressure, then only the piston will go up. That means, can I say work done by the system? Clear till here? Here what does the work done will be negative. Okay, whereas in compression means what? Suppose the piston is here. Okay, here it's written what? 3 liter. At 3 liter the piston is there. Compression means what? Piston has to come down. Now piston reached to which level? 1 liter. Okay, now when does the piston will come down? If we apply the pressure or system apply the pressure. If we people apply the pressure, then only that piston will go down. Okay, so that means here work done on the system, that means work done will be positive. From this what you have understood? Whenever the question is related to expansion, work done is always negative. Whenever the work done is related to compression, work done is always positive. Okay, and one more thing here, what about the volume? Okay, so before the volume was 3 liter, after the volume became 5 liters. Okay, what is the change in volume? Then change in volume is nothing but 5 minus 3, which is nothing but plus 2. Okay, 2. That means can I say there will be volume will be positive. Clear till here? So that means work and volume both are opposite to each other. Whereas here, what is the change in volume? After it is 1 liter, before it was 3 liter. That means you are getting minus 2. That means under which case volume is negative. Yes, whenever we are talking about compression. So work done and volume are, these are always opposite to each other. Okay, moving to the next one, second category of the work. So here work is divided into two types. It may be reversible or it may be irreversible. Okay, so coming to the next one here, work. Okay, so this time what happened, work is further divided into two types. Okay, it may be wait a minute.